Hi, my name is Athena from Dreamforge Academy. I will be your guide for this course. It's Tuesday evening. You ask your assistant what happened in your app this week, and it has no idea your app exists. So you open a tab, take a screenshot, paste it in, and describe what it shows. You've become a very expensive cable between two pieces of software that both run on machines you own. This course closes that gap. You'll end up with a working connection inside the app you already shipped and an assistant that can use it. The hard part isn't the plumbing. It's deciding whose permission a tool call runs on. Strip the vocabulary away and the shape is familiar. Your app publishes a short menu of things it can do. Each item is a tool, a named function with described arguments. The assistant asks for the menu, picks the item that fits, calls it, and your app runs the function and returns text. The transport is plain JSON over an ordinary HTTP post to one route. That's the whole mechanism. The Model Context Protocol is an open standard for that exchange. The SDKs get pulled down about 200 million times a month, so this is settled ground. Every tool call is somebody using authority. The only question is whose. A shared API key is quickest. Paste one long secret into the assistant's config and trust anything carrying it. But a key isn't a person. You end up with a second permission system that drifts, revocation nobody gets round to, and logs that name the key instead of the human. A service account looks tidier and is exactly backwards. It holds every permission the tooling might need, so a part-timer's assistant can change records that person can't touch. That's the confused deputy. The third answer is what we teach. Sign in as yourself, and the tool calls the same function the button calls. Before you write anything, go and knock on a door that's built correctly. The Academy's own server is live. Send an unauthenticated post to its MCP route, and you should get a 401 back, plus a www authenticate header naming the scopes it wants and pointing at a discovery document. That header is how an assistant that has never seen your app works out where to send its user to sign in. Then fetch the document it points at and read the resource value closely. One exact URL, no trailing slash, and check which of the site's domains it names. Last, repeat the first request as a GET and confirm you get 405. 3 commands, 3 things to check. The post comes back 401, not 200 with an error inside. A 200 reads to an assistant like an ordinary tool failure, and it never starts the sign-in flow. The header names scopes and points somewhere real. The discovery document gives one exact resource URL with no trailing slash on the domain you expected. Get returns 405, which tells you the route accepts post and nothing else. And here's the one you'll build toward. After someone clicks disconnect, the very next call carrying the same unexpired token comes back 401. MCP lets an assistant call named functions in your app for a signed-in person over plain JSON on one route. It isn't a database connection, a plugin runtime, or an authentication system, and that last gap is where the vulnerabilities live. Your assignment is a single page for the app you actually shipped. List up to 10 things you'd want an assistant to do, mark each one red or right, and for every right name, the exact function your own UI calls today. Then write the audit line you'd want afterwards. If you can't fill in a human name, the row isn't ready. Thank you for watching. Follow along using the course material and complete the lesson assignment. I will see you in the next lesson.